Go through an example of a kinematics problem. So it's a little artificial, it's a little cute, but it gets you a step along the path to thinking about projectile motion or motion in more than one dimension. So here's a setup. Key falls from a bridge that is 45 meters above the water. It falls into a small boat, so my little pea green boat here. The small boat is moving with a constant velocity that was 12 meters from the point of impact when the key was released. So basically the key is going to fall into the boat, and the boat has moved over far enough for the key to fall into the boat by the time it reaches the water. And we want to find two separate things. What is the speed of the boat? And then how fast is the key moving right before it lands in the boat? So we have two unknowns that we're trying to solve for. And I have put in my choice of coordinate axis. I don't have any other reason to, pick things aside from motion to the right is the positive x direction and motion up is a positive y direction. And with that choice of coordinates, the motion of the key, as we will see, is completely independent from the motion of the boat, except for the fact that they have the same time variable. So let me go through and put together an inventory of variables for motion of the key along the y direction and motion of the boat along the x direction. So for our key, the final time, I do not know. So that's an unknown. The key starts at a coordinate of 45 meters along the y direction. It ends at 0. The initial velocity, so the y component initial is what the y and the o are there for. We're going to drop it. So it starts at rest. The final component of the y component of the velocity is not known. And in fact, we need that to answer the second question. What is the speed of the key right before it lands in the boat? And the acceleration along the y direction, if I keep two digits, because my data has two digits going into this, minus 9.8 meters per second squared. Okay. Minus sign is because I picked up to be the positive direction. And we have the acceleration due to gravity, which is downward pointing. Do the same inventory for the boat. And also I would mention that there is in principle another kinematics variable here, but by default in your textbook that is taking the value of 0. So the initial time we're taking to be 0. So I'm not writing that out. Okay, final time. I don't know that for the boat either, but it's the same. Same variable is the same quantity. The initial x position for the boat, don't have any reason to pick it other than 0, because what matters is at the final position, the boat is 12 meters to the right. So the displacement is plus 12 meters, and I don't care how you do that. It could be 24 and 12, or however you want to do it. But the displacement has physical meaning. It is 12 meters to the right. The x component of the initial velocity, I do not know, but I know that it is equal to the x component of the final velocity. It's an unknown. We need that to answer the first question. What is the speed of the boat? And the velocity is not changing along the x direction, so that is a goose egg, 0. All right. I want to find the time it takes the key to fall 45 minutes, or 45 meters. And then once I have that time, we can use that to find the speed of the boat, because the boat will have moved 12 meters in that time. And we can also find how fast the key is falling from kinematics. All right, so the way I'm going to choose to solve it is based on finding this final time first. It's not the only way you can do it, but it's the way I'm going to work it out. So we want a kinematics equation that involves time, and time is the only unknown. And the one I'm going to start with is that y minus y naught is the initial velocity along the y direction times time plus a half acceleration along the y direction time squared. And we're just dropping the key, so it's starting from rest. So that is 0, so we can throw out that whole term. That tells us that y minus y0 is minus 45 meters equals a half minus 9.8 meters per second squared times the time squared. And so the only unknown is the time. We can solve for that. Let's hop over the next page to do that. So we have a quadratic to solve for. So the time will equal plus or minus, it would be 2 times 45 minutes over 9.8 meters per second squared, all square root. And that is going to give us plus or minus 3 seconds. So you can tell it's a physics problem because it worked out to have a nice round number. Out of those two roots, the plus and the minus, we want the positive root because we want the final time to be in the future. The negative root also does have physical meaning, but that is going to correspond to throwing the key upward from y equals 0 to reach y equals 45 minutes, 3 seconds in the past before time equals 0. Okay, so this is what we want, and so we can fill in that the final time is 3 seconds if we're being super careful with our inventory. And now we can go through and address the 2 questions. For the speed of the boat, it's going to be the displacement of the boat over the final time, and that is 12 meters in 3 seconds. It's 4.0 meters per second, about 8 miles per hour, not an unreasonable speed. And then the final speed of the key, we can use acceleration along the y direction is equal to final minus initial y velocities over the final time, since we're taking t0 to be 0, and that is 0. So final y velocity is going to be the acceleration along the y direction times time. So we've got a minus 9.8 meters per second squared times 3 seconds is going to give us to 2 digits minus 29 meters per second. So the speed of the key, speed smallest it can be is 0. It's the magnitude. Speed of boat is 4 meters per second, and the requested speed of the key, get rid of the minus sign, is 29 meters per second. And then both answers are written out to have 2 digits.